Hey everyone, and welcome to This Explainer. Today we're taking a real builder's journey, going all the way from creating smart, front-end bots down to exploring the completely microscopic back-end hardware that actually powers them. Now you might be wondering, why does this even matter? Well, because truly understanding the hardware layer fundamentally changes how you write software at the top. When you know exactly what the silicon is doing under the hood, your code becomes radically more efficient and, well, just way more powerful. I am incredibly excited to guide you through this full stack, so let's jump right in. Let's start things off with something kind of mind-blowing. Google's experimental Gemini 2.0 Live API is literally giving AI human-like senses, and it's opening up some absolutely incredible possibilities for what you can build right now. It has sight to analyze live camera feeds, it has hearing to process audio, and get this, it communicates with actual emotional intelligence. That means the AI can pick up on your tone of voice, detect if you're frustrated or maybe just really happy, and it adjusts its response dynamically, exactly like a real person would. Oh, and it can even analyze your live desktop screen directly. So we're not just talking about text anymore. This is a full-blown multimodal powerhouse. Okay, here's our roadmap for today. We'll cover the Gemini Live API, securing your API keys, the Agentic AI evolution, CPU versus GPU processing, the microscopic hardware titans, and finally, CUDA, the AI engine. Section 1. The Gemini Live API, multimodal power at your fingertips. So using the Google Gen AI Software Development Kit, or SDK, you can easily connect your own machine directly to Google servers without having to write all those complex HTTP requests. I mean, think about the absolute headache developers used to go through, right? Dealing with heavy REST API protocols, configuring webhooks, and managing all that complex routing just to send a simple text prompt. It was exhausting. But now, this SDK turns days of back-end routing into literally just a few simple lines of Python. You just install it and boom, you have a direct bridge from your local Python environment straight to Google's massive AI Studio servers.
Section 2. Securing your API keys. Don't leave the keys in the car.
You really have to think of your API key like the keys to your car or even your house. If you leave them hard-coded in a public script, anyone can just come along and take them. And the stakes here are very, very real. A leaked API key on a public GitHub repo can be scraped by malicious bots in seconds, and that can result in tens of thousands of dollars in unauthorized bills hitting your account overnight. Nobody wants that. So to stay safe, here's what you do. First, generate your key securely in Google AI Studio. Second, save it as a secret in your Google Colab environment. And third, load it safely into your code using OS environment variables. Doing this ensures the key stays completely hidden on the system level and your codebase stays totally safe. Section 3. The Agentic AI evolution, from calculators to autonomous advisors. To really grasp how AI has evolved, let's compare traditional monolithic AI to a compound AI system. Traditional AI is kind of like a basic calculator. It has a rigid, monolithic architecture that only performs one specific, trained task, like, say, looking at a picture and determining if it's a cat. The huge problem there is retraining. If you suddenly want that exact same AI to detect dogs, you essentially have to tear down and rebuild the entire calculator from scratch. It's just not flexible. But a compound AI system, that's more like a smart budget app. It acts like a cohesive toolbox that calls multiple separate functions to get a complex job done, like calculating some math, fetching data from an external database, and then saving an event right to your calendar. It gives you massive flexibility. Now, Agentic AI takes that whole toolbox concept and makes it completely autonomous, which fundamentally shifts how software operates. Instead of a human sitting there telling the AI exactly which tool to use at every single step, the agentic layer actually reasons and acts on its own. Imagine asking an AI to schedule a meeting. A standard system would just wait for you to fetch your free time and manually set the calendar tool. But an agentic system? It acts like a proactive personal assistant. It will automatically figure out your free slots, check the calendar, and just book it for you, without any further prompting from you. It's brilliant. Section 4. CPU versus GPU processing. The hardware driving the intelligence. So how do these massive models process information so quickly? Well, think of a standard central processing unit, or CPU, as a solo local mechanic. They process tasks sequentially. That mechanic has to look at the car, fix the tire, walk over to the engine, and then check the oil. One slow step after another. But graphics processing units, or GPUs, they handle parallel processing. They are like a blisteringly fast Formula One pit crew. The very second that car pulls in, multiple experts immediately jump on different parts of the car concurrently. One does the fuel, three handle the tires, all at the exact same millisecond. Modern AI absolutely requires this F1 pit crew approach to quickly crunch staggering amounts of data all at the same time.
Section 5. The microscopic hardware titans. The silicon making it possible. Okay, let's zoom way in. The size of upcoming semiconductor technology is just 2 nanometers. Now, to put that into perspective, just how small is 2 nanometers? It is actually smaller than a single strand of human DNA. Let that sink in for a second. If you stack them up, 50 million of them would fit into a single centimeter. At this scale, you can't even see the physical structure with a standard electron microscope. You literally just see a glow. It's absolutely mind-blowing that we can print billions of functional working components onto a chip this incredibly tiny. And here's a really fascinating detail. While massive companies like NVIDIA, Apple, and Qualcomm design the brilliant architecture of these chips, like the 4nm RTX 4090 or the 3nm Apple A18, they don't actually physically build them. They are entirely manufactured or fabricated by one major company, TSMC in Taiwan. This dynamic makes TSMC one of the most geopolitically and economically critical companies on the entire planet. Their incredibly complex fabrication plants hold the actual keys to turning global tech designs into physical silicon. They are the singular powerhouse for the world's technological advancement. And NVIDIA is pushing these physical boundaries even further. Their next generation, called Blackwell, is arriving in early 2025. Instead of a single chip, Blackwell actually features 2 chips working tightly together. It's like having 2 master chefs cooking in the exact same kitchen. This dual chip setup is going to deliver 30% more speed while remarkably using 25% less energy than the previous generation. And, that energy savings is massive because right now, raw electricity consumption is the single biggest bottleneck preventing global AI from scaling even faster. Because of this continuous hardware dominance and wild innovation, NVIDIA currently holds a staggering 92% market share in the AI computing space. They are, without a doubt, the undeniable heavyweight champions of the parallel processing world. Section 6. CUDA, the AI engine, connecting software to silicon. But, all that amazing hardware is basically a paperweight without the right software to run it. Let's trace how NVIDIA's CUDA driver evolved from a neat gaming tool into the engine that ignited the entire AI revolution. Back in 2006, NVIDIA introduced CUDA for general-purpose parallel processing, which was initially just aimed at rendering video game graphics faster. Then, in 2009, they added a specific library for artificial neural networks, called CUDA-NN. This allowed massive math operations for AI to run natively on GPUs. And then came 2012. CUDA powered an AI model on the ImageNet dataset that absolutely crushed traditional algorithms, jumping accuracy from 72% to 84%. This wasn't just some incremental software update. This was a watershed moment in human history. It proved definitively that GPUs were the undisputed future of machine learning. And that's why today, CUDA is the dominant standard. Why do developers love it so much? Because it offers native integration with major languages like Python, C++, and Java. For a developer, this means absolutely everything. Without CUDA, you'd have to write complex, excruciatingly low-level hardware code just to get your program to talk to the GPU. But with CUDA, you just use standard Python, and all that complex hardware translation happens magically underneath. It's built natively into massive AI frameworks like PyTorch and TensorFlow. It offers a huge ecosystem for parallel processing, like physics simulations, and crucially, it allows developers to easily scale their models, running across multiple GPUs simultaneously with total ease. So we have covered a lot of ground today. You now understand the full stack, from setting up secure Python API keys to bridging to Google's Agentic AI, all the way down to 4nm silicon and the incredible CUDA software that glues it all together. We've gone from the conceptual code down to the microscopic hardware. You now possess the exact same foundational knowledge and tools that the world's largest tech giants are using every single day. So the only question left for you is, armed with all this power, what kind of startup or tool are you going to build next? Thanks so much for joining me for this explainer, and I really hope it sparked some amazing ideas for your next big project.